Welcome to another exercise in the workbook Statistics. This time I'm going to talk about an exercise focusing on the comparison of means, or rather testing whether the arithmetic mean of a sample is within reasonable bounds of a given, value or previously defined mean. So let's have a look at the exercise here. Our task is, in the context of a market research study, the following rating scores on a scale of 1 to 7 are collected for a particular product. Then we have those informations. And our task, the company considers taking the product off the shelves if the rating score drops below 4.2. Use a suitable test to check whether the product will be taken off the shelves, assuming a margin of error of 5%. Well, if we look closely, what we see here is we do not have any information regarding the standard deviation or the variance of the sample, and we have clearly less than 50 or 30 observations. So we have to use a t-test in this context. For the t-test, we need, 4 informations. The first of them being the arithmetic mean. The arithmetic mean is relatively easy. We simply add up all the values, divide them by the number of observations. So adding all of this up, dividing by 10, yields a result of 4. This 4 we are later going to compare to the given value of 4.2. But before we get there, as I said, we do not have any information on the variance or the standard deviation, so we have to calculate this. Here, I'm going to do this in a very easy way by simply subtracting from each value the arithmetic mean we just calculated and then squaring the result. As I said, I'm going to do this for each value and then adding up all the partial results. The final sum is then divided by the number of observations minus 1. Here I have 10 observations, so I'm dividing by 9. This already gives us the variance, or rather the corrected variance, the sample variance, which is here 3.333 and so forth. However, what we're going to need in the context of determining a test statistic is the standard deviation. So we're going to take the square root of this, yielding us a standard deviation of 1.8257. So far, so good. In addition to all of this, we also need a respective quantile from the t-distribution. As I said, we're going to do a t-test here, so that's why we're using the t-distribution. The respective quantile is t n minus 1, 1 minus alpha. N was 10, so we have as a first value 9. Then 1 minus alpha, alpha being the margin of error. Here we have a margin of error of 5%, so we're going to subtract 0.05. So we have the value t9, 0.95. This value we can look up in the table for the t-distribution. Then we're going to find a value of 1.8331. So that's the value we're going to use for the respective quantile. So first off, I'm summarizing the results we have determined before. We have the arithmetic mean, the standard deviation, and the respective quantile of the t-distribution. Then we have the number of observations and the test value. In this regard, some of you might be wondering, why did we use this quantile? Why did we use this with 0.95 and not 0.975? Well, in this case, what we're actually working with is a one-sided test, because they're only taking it down if it's below 4.2. Not if this is above 4.2. If we're using the standard t-test, which would simply test, is there a difference between these two values? Then it would be a totally different exercise, and then we would use 0.975. Here, this is a one-sided test. We're going to test whether this value is really significantly smaller than that value. Well, with this said, we can calculate the corresponding test statistic with the standard formula for the t-test, which is just the square root of the number of observations, so the square root of 10, then the difference between arithmetic mean of the sample and the test value, and dividing this difference by the standard deviation, which is calculated here. So in the end, we get a result for the test statistic of minus 0.3464. This might look strange since it's negative, but this doesn't matter, because what we're going to do in the next step with the test statistic, we're going to consider only the absolute of this value. And we take a look whether this absolute is smaller or larger than our quantile of the t-distribution. So that's automatically our reference statistic. Since here in this case, the test statistic, or the absolute of the test statistic, is smaller than the reference statistic, the quantile from the t-distribution, we can say that our H0 hypothesis cannot be rejected. What does this mean? Well, this means that the arithmetic mean of 4, does not significantly differ, is not significantly smaller than our test value of 4.2. This means that they should not or do not take the product off the shelves, because it's not yet significantly below the critical value they set. Well, that's about it on this exercise. I hope you enjoyed it. I say goodbye and see you next time.